question number 9B. Question 9B. We will start with question number 9B. We can go through the question. We can be able to see the diagram. We can be able to see the diagram. We have gone through. From the diagram, the chlorine is passed. The chlorine is passed of a hot aluminium. Of the hot aluminium, and the reaction continues. The question number 1 there is about reacting chlorine with the aluminium. From the diagram, we can be able to see that the aluminium react with the chlorine, and the product that is formed at the far end there. And from the same, then we can see that the product that is formed has got the ability to sublime. It is formed far away from where the reaction is taking place. Then the other question is naming the substance A. The substance A is therefore aluminium chloride. Writing the equation is aluminium plus chlorine, you get aluminium chloride. State the function of the calcium chloride in the setup. The role of the calcium chloride in the setup is to absorb water vapor. That is why it is put at the top there, to absorb any water vapor, because the aluminum chloride can absorb that water vapor and change its crystalline form. Then we can go to the other question. The other question now is on the topic nitrogen. The topic nitrogen. The apparatus below was set up to show the catalytic oxidation of ammonia. Study the diagram and answer the questions that follows. You can see the dry ammonia is passed through, and then there is the nichrome wire. Then the question is about write an equation for the reaction that is taking place. Inside the jar, dry ammonia is being put, and of course there is air. So there we are going to have ammonia reacting with air in presence of the nichrome wire, which is acting as a catalyst. So when ammonia is oxidized through a catalyst, then nitrogen 2 oxide is formed. So we are going to form nitrogen 2 oxide and water. Why is it necessary to have the hot nichrome wire in the gas jar? The nichrome wire, in that case, one, will act as a catalyst, and then because it is hot, the hotness will, the high temperature will initiate the reaction, and then it is also acting as a catalyst. Write the formula of the complex ion formed when excess ammonia is passed through a solution containing zinc ions. Ions are got from a soluble salt. Let's give examples of soluble salt of zinc. Zinc sulfate, zinc chloride, zinc nitrate, zinc chloride, I said, zinc nitrate, zinc sulfate. When those solutions are formed, inside them, there is the zinc ions. Ions are only formed in a solution that is soluble. That is why I have given examples of soluble salts. If ammonia is bubbled in either of those zinc soluble salts, when the reaction of the zinc and the ammonia hydroxide take place, then the zinc hydroxide, which is an insoluble white precipitate, will be formed. And when excess is put, the zinc hydroxide will react with excess ammonia. So in the equation, it will be zinc hydroxide plus ammonia, NH3 aqueous. And a complex ion will be formed. In that complex ion, the ammonia will attach itself on the zinc ion as NH3, such that we are going to form one zinc. NH3 will be how many? Will be 4. So we'll form zinc, NH3 will be 4, and then we bracket and put a charge of positive 2. And that is what we call tetraamine zinc 2 ions. We move to question number 2. I hope I am clear. We move to question number 2. In question number 2, there is the diagram there of the catalytic oxidation of ammonia. That question is like the other one we have done up there. But this one is a bit different in the fact that the oxygen is the one that is being put in concentrated ammonia solution. The concentration ammonia solution is giving out ammonia gas or ammonia fumes. So ammonia fumes will move from the solution and they react now with oxygen on the surface of the hot rod M. That hot rod M is a catalyst, and it is it is a catalyst that is platinum. So there is a question down there asking, what is M? M is hot platinum. platinum will act as a surface where the two gases will react on. At the same time, it is also acting as a catalyst to speed up the reaction. And the reaction is also catalytic oxidation. The ammonia will react with oxygen to form nitrogen 2 oxide, and the other product will be water. So that one is also catalytic oxidation of ammonia, because ammonia is being oxidized by oxygen in presence of a catalyst. The role of the platinum there, which I said M is platinum, the role of the platinum is acting as a catalyst. And when ammonia is oxidized in presence of a catalyst, it forms nitrogen 2 oxide, and the other product is water. We can check down to the next question. The question that is next there after the diagram. What is M? I have said M is platinum. State and explain two observations made in the conical flask. In that conical flask, the platinum is said to be hot. So when it is hot, it will be glowing, GLO, will be glowing red when it is hot. When it is being put, it will be glowing red. And as the reaction continues, the observation that will be made is that it will continue to glow. It will continue to glow red because the reaction between ammonia and oxygen is exothermic. It will produce heat to maintain the hotness of the platinum. The platinum will continue to glow red. That is one observation. The hot platinum will continue to glow. That is one observation. The other observation is that the nitrogen 2 oxide that is formed will get oxidized to nitrogen 4 oxide, and the observation will be brown fumes. So brown fumes is another observation. Brown fumes is another. We move now to question number 3. Ammonia gas is prepared in the laboratory in the action of an alkali and ammonium salt. A student wanted to prepare a sample of ammonia gas in the laboratory. As you can see in the diagram. The ammonium chloride mixture and the alkali are heated together. Question number 1. Give an alkali that can be used in the experiment. Then the other question, write an equation for the reaction that is taking place. From the diagram, the ammonium chloride is being reacted with an alkali. The alkali there can be any soluble base is called an alkali, and the most appropriate one that is used is calcium hydroxide, such that now the reaction is going to be calcium hydroxide, which is the alkali, being reacted with, excuse me, being reacted with ammonium chloride. So ammonium chloride, calcium hydroxide, the product will be calcium chloride, ammonia gas, and water. I repeat, ammonium chloride reacting with calcium hydroxide, the product will be calcium chloride, ammonia, and water. Writing the equation, NH4Cl, that is ammonium chloride, calcium hydroxide, CaOH into bracket 2, calcium chloride, CaCl2, ammonia is NH3, and of course H2O. That is the equation. That is, that's how to write that equation. And then where there is ammonium chloride, we put a 2. Okay. We are now on the other question. Explain the importance of high percentage of nitrogen in the air. Importance of nitrogen in the air, then the percentage of nitrogen in the air is 78%. That is the highest amongst the gases that are in air, followed by oxygen. Oxygen is 20%. Then we have carbon dioxide. So the highest percentage is nitrogen. And it has got a very great role in the air. The fact that it is inert. It is not very reactive. So it is the one that brings inertness. When burning is taking place, the nitrogen bring the inertness, and burning does not continue uncontrollably because the highest percentage is nitrogen, but not oxygen that supports combustion. So burning will not just continue, will not take place continuously because of course there is another inert gas not support the burning. The other question is, why is nitrogen used in the storage of semen for artificial insemination? That is negative. Nitrogen has got a very low boiling point of negative 196 degrees Celsius. That is one reason why it is used as a refrigerant. Low boiling point of negative 196 degrees Celsius. Another reason, it is because it is inert. That inert atmosphere now make it to be used as a refrigerant. Then it is also non-flammable. Those are the 3 reasons that make nitrogen to be used as a refrigerant. I said low boiling point of negative 196 degrees Celsius. Number 2, it is inert. Number 3, it is non-flammable. We move to the next question. The next question is also a diagram, and the diagram ammonia nitrate is being heated and a gas X is being given out. And then we have, you can see the way the ammonia nitrate is being heated. Then the gas is being collected over the water method. From the diagram, when ammonium nitrate decomposes, the gas formed will be, gas X will be nitrogen gas. The other product definitely will be water, but our interest is the gas X. Gas X is nitrogen. Looking on the question number B, the physical property, the first one is got from the method of collecting the gas. From the method of collecting the gas, then the gas is insoluble in water. The gas is insoluble in water. Other physical properties of nitrogen is that it is colorless, it doesn't have a smell, it is insoluble in water. In writing, when writing that equation on how nitrogen is formed, the NH4NO2, that's how we write the ammonium nitrate, and then an arrow. On top of the arrow, we put heat. The product then is going to be N2, and the other product is going to be H2O. That is the water vapor. Then in front of the water, to balance that equation, in front of the water, we put a 2, so that we can have 4 hydrogen on the product side and 2 oxygen on the product side, just like the way it is on the reactant side. So in front of the water, we put a 2 to balance the equation. Moving now to the next question there. Give one commercial use of X. X, which is oxygen, one use is the one that we have seen up there. It is used as a refrigerant. In storage of, in artificial storage of semen that are used in artificial insemination. That is one use of nitrogen. We can move on to the next diagram. The next diagram is a question on a certain solution A. The solution A is added excess ammonia on one, the first step, and a white precipitate is formed. Then, when it is added dilute sulfuric acid, a white precipitate is also formed. To answer that question, we move back to which cations will form white precipitate when ammonia in excess of ammonia. They are, one of them will be magnesium, the other one is aluminium, the other one is going to be calcium. I said aluminium, calcium, and magnesium. They will form white precipitate in excess ammonia because they do not dissolve. Magnesium, aluminium, calcium. Then we also have lead ions. Now, to help us identify which one amongst the four, then there is another test that is done, putting sulfuric 6 acid. To help us eliminate the others, we'll be left with one answer. So when aluminium ions are added sulfuric 6 acid, there will be no white precipitate. So it will not be ammonia. Solution A cannot be ammonia. It can also not be magnesium because for magnesium, when dilute sulfuric 6 acid is put, we form magnesium sulfate, which is a soluble salt. When put sulfuric 6 acid in lead ions, definitely will form lead sulfate. And lead sulfate is an insoluble salt. So that solution A is likely to be lead. And because it is a solution, the question down there is asking about a solution. The only soluble salt of lead is lead nitrate. So that solution A can only be lead nitrate. Because lead nitrate will form white precipitate when it is added dilute sulfuric 6 acid. Then we move to the other question. To the other question, that is on solution B. When solution B is added excess ammonia, a white precipitate is formed. When solution B is added dilute sulfuric 6 acid, no white precipitate is formed. In excess ammonia, the precipitation we had already seen in the first, up there. They can be magnesium, can be aluminium, can be lead, can be magnesium, can be aluminium, can be lead. This time, when put dilute sulfuric 6 acid, there will be no white precipitate. Therefore, it will not be lead, because lead will form lead sulfate, which is a white precipitate. Now we are left with magnesium and aluminium. So it can either be magnesium, because for that case it will be magnesium sulfate, which is soluble, or aluminium sulfate, which is also soluble. Therefore, that solution B contain or may be containing magnesium ions, can also contain aluminium ions. So we have answered the cations present in solution A is lead ions. The cation present in B are magnesium ions, aluminum ions. State and explain the observation made when a sample of dry white precipitate is heated in a test tube. Precipitate B. Precipitate B, of course, is a hydroxide. It will be a hydroxide. So take magnesium nitrate, add ammonia hydroxide, then the product is going to be magnesium hydroxide plus ammonium nitrate. B is magnesium hydroxide. B is and then it is heated, will form an oxide, that is magnesium oxide. The other product is going to be water. When a hydroxide is heated, it decomposes to form an oxide and water. When a hydroxide is heated, it decomposes to form an oxide and water. So in that case, magnesium hydroxide decomposes to form magnesium oxide and what observations are going to be made in that case? What observations are going to be made in that case? The water vapor, when anytime water vapor is formed, when a reaction is taking place, colorless fumes will be formed at the coolest part of, this is a boiling tube, I mean, it is a test tube. Colorless liquid will be formed at colorless liquid will be formed on the cooler part because water is being formed. So on the coolest part of the test tube, colorless liquid will be formed. That is the observation that will be made. In terms of the color, there will be no change because magnesium hydroxide will be a white solid, and still when you heat it, it will still be a white solid. So definitely the color change of the solid is not, there is no change. But at least because we are starting with a dry one, then when it decomposes, then you can be able to see the colorless liquid. We move to question number 7. Question number 7. Question number 7 is a diagram, and I hope the work that I am giving, you had already gone through the questions. And so I'm giving the answers as you mark the work. The dry set, the setup arrangement, it is showing how metal react with nitrogen 4 oxide. Nitrogen 4 oxide is reacting with copper, as you can see. Then a gas N is a gas N is formed. Nitrogen 4 oxide is being passed on hot copper and a gas N is being formed. This question is testing on how metals react with nitrogen 4 oxide. Nitrogen 4 oxide, when it reacts with a hot metal, the heat of the hot metal decomposes the nitrogen 4 oxide to nitrogen and oxygen. The product in that case now will be the copper plus NO2. The product that is formed is going to be copper 2 oxide and nitrogen gas. Because when nitrogen 4 oxide decomposes, that oxygen will oxidize the copper. And then the other product is going to be nitrogen. In that particular equation, then we can be able to see that nitrogen 4 oxide is acting as an oxidizing agent. It oxidizes the copper to copper 2 oxide. And now the other product is nitrogen. So in the setup, the gas that is being collected there is going to be nitrogen gas. Looking at the question, we can move it so that we can be able to read the questions that are below there. We can move to the next question. The next question that is below the diagram. We can move to the next question. The question below. Nitrogen 4 oxide is passed through That equation had said that in that equation, the copper 2 oxide can also, the copper 2 oxide formed, it is formed as a result of oxidation of copper by the oxygen from the nitrogen 4 oxide. And the same can be repeated there by replacing the copper. Copper can also be replaced by any other metal, any other hot metal, be it lead, be it zinc, be it magnesium. As long as it is hot, it can be oxidized by nitrogen 4 oxide, because the heat of the hot metal will decompose the nitrogen 4 oxide to nitrogen and oxygen. And that oxygen will now oxidize the metal that is reacting. I said be it copper, be it lead, can be magnesium, can be magnesium, can be zinc. Then we can move to the other question. Like that. In the Haber process, hydrogen and nitrogen react in presence of finely divided iron. Explain why the catalyst is finely divided. Finely divided is powder. There is the powdered metal. Then we also have the granules. We also have the tannings. So when we are talking of finely divided, it's like powder. And a powder, if you look on the particles of a powder, they are very small. And the smaller the particle, the greater the surface that is exposed. And the surface exposed for the reaction, if it is greater, then it increases the rate of reaction, because the area of reaction is larger. The area of the reaction is larger. So why do we have 8 being divided? To increase the surface area for the reaction. To increase the surface area where the reaction is taking place. On the same, though not in that question, it is also made more efficient by adding aluminum oxide. Another point that we can add on that question is that it is also made more efficient by adding aluminum oxide. The other question is a mixture of nitrogen and ammonia, nitrogen, hydrogen, and ammonia was bubbled through 0.2 molar hydrochloric acid solution. The final concentration of the acid was found to be 0.1 molar. Give an explanation. Though we have not learned the topic of molarity, that is the topic of moles, 0.2 definitely, from simple now mathematics, 0.2 is greater than 0.1. I mean, 0.2 has got more of the acid than 0.1. And so in that case, the ammonia there, because ammonia is basic, at least that one we know. When ammonia is put in an acid, ammonium hydroxide, and now the acid has got hydrogen ions, then there is going to be some neutralization. So some of the hydrogen ions will be reacted on by the hydroxide ions, making the concentration or making the amount, because concentration is the amount of the solute. And in this case, the solute is the HCl that was put in water. So if the hydrogens are reacted on, that one will reduce the amount of the hydrochloric acid as a result of the ammonium hydroxide reacting with some of the acid, making it to be less or to decrease from 0.2 to 0.1. Then question number 9, in an experiment, a few drops of concentrated nitric acid were added in aqueous iron 2 sulfate in a test tube. Excess ammonia was then added to the mixture. State the observation that was made when concentrated nitric acid was added in iron 2 sulfate. That question is testing on the properties of concentrated nitric 5 acid. And one of them that we can be able to see there is that it will react with iron 2 sulfate, and the product that is going to be formed will be nitrogen. We will form nitrogen 2 oxide. We will form water. And the other product that is going to be formed there is going to be iron. Iron will change from iron 2 to iron 3. Therefore, the property there is oxidation. It oxidizes iron 2 to iron 3. And the other product that is going to be formed is nitrogen 2. So the nitric 5 acid will be reduced to nitrogen 2. And the other product will be water. So the color of iron 2 is green. And it is oxidized to iron 3. So the color will change from green solution to a yellow solution. Reason, iron 2 are oxidized to iron 3. Then excess of ammonia was added to the mixture. When excess of ammonia now is added to the mixture of iron 3 sulfate, nitrogen 2 oxide, and water. And then ammonia is put in that mixture, and still in the mixture, we can read the question again. A few drops of concentrated nitric 5 acid were added in aqueous iron 2 sulfate in a test tube. Then in the same test tube, excess ammonia was put to the mixture. Now you can see the product is iron 3. In the first step, iron 2 was changed to iron 3. That is the first step. Then in the second step, now excess ammonia is being put to iron 3 ions. So in that case, the iron 3 hydroxide will be formed. So brown precipitate is going to be formed. Brown precipitate will be formed. So when writing the ionic equation for the reaction that occurred in Roman number 2, when a precipitate is formed, what is the precipitate? The precipitate is iron 3 hydroxide. So we write it on the product side. And then on the reactant side, how was it formed? By iron 3 ions plus 3 hydroxide ions. So the equation, the ionic equation, when we are writing the ionic equation, it is the ions of the precipitate that are written. So we have iron 2 ions plus 3 hydroxide ions to get iron 3 hydroxide. That is the equation for the reaction that occurred in Roman number 2, formation of iron 3 hydroxide. We can move to question number 10. Question number 10. Question number 10 is clear to us. It is a chart that is showing the summary in the preparation of nitrogen gas from air. Nitrogen gas from air. In the first case there, the gas is being, the air has got nitrogen, oxygen, carbon dioxide, water vapor, and noble gases. When that air is passed over sodium hydroxide, the part of air that reacts with the sodium hydroxide will be carbon dioxide. So after the sodium hydroxide chamber, the air will not be having carbon dioxide. Then the process continues and the air is then passed over hot copper. Hot copper will react with which part of air? Oxygen. So the copper will react with oxygen from the air. And so after that chamber, the air will not be having what? The air will not be having oxygen. Then the only gas now that is remaining in Roman number 3 is nitrogen gas, because CO2 has been removed and oxygen has also been removed. And nitrogen is remaining because nitrogen does not react with sodium hydroxide. It does, because of its inert nature, it does not react with copper because of its inert nature. Though we know that the very reactive metals like potassium, sodium, the very reactive metals like potassium, sodium, and calcium, and magnesium, they can react with nitrogen. But for copper, because it is not a very reactive metal, it does not react with nitrogen. What is the purpose of sodium hydroxide? To remove carbon dioxide. Write an equation for the reaction taking place in chamber 2. The reaction that is taking place copper plus oxygen to get copper 2 oxide. Cu plus O2, then you put an arrow, then the product is CuO. Is it balanced? No. Balancing it by putting a 2 in front of copper and a 2 in front of copper 2 oxide. Copper is a solid, oxygen is a gas, copper 2 oxide is a solid. Then the other question is asking whether and why the nitrogen is not pure. Definitely it is not pure because it may be having what? Or it is having noble gases, e.g. argon. It is having noble gases, e.g. argon. So it is not pure. It has got argon because argon, the noble gas, has not been removed in the process. I said the gas nitrogen obtained is not pure because it contains noble gases, e.g. argon. We move to the other question, question number 11. And I hope you are still marking your work. We move to question number 11. We can move to the next question, question number 11. And I hope you are following. I said, because you have already done the assignment, I am taking you through the assignment here as you mark your work. So that now when we get back there, we will be able to check your work. The way we have given the answers, are you following? Are you writing the corrections that way? So we move to the next question, question number 11. We move to question number 11. This is a question on, I hope you are able to keep up with my speed. This is a question on the topic of sulfur. And it is the fresh process. And this question is showing a diagram of the fresh process. Fresh process is the extraction of sulfur from the sulfur bed. This concentric pipes method is the most suitable one to extract sulfur because sulfur beds are normally located in very weak and sandy ground that are not very strong. So putting the pipes, the concentric pipes, is the most suitable method. These pipes, as we can see, we can go through them. We can go through the diagram. The one that starts is the one that is labeled L. L is, L is the middle one. Then we have J is the innermost. Then K is the outermost. So we start with the outermost. The outermost is the widest in terms of diameter, and it is the one that is put first on the ground, and it reaches to where the sulfur beds are. Then the other one that is put is the middle one. It will also reach to where the sulfur beds are, and then finally the inner one. And each one of them has got a different role. What is the role of the widest? That is the K. K contains K contained superheated water. Super means the water is above the boiling point. It is 170 degrees Celsius. That is why we are saying it is superheated. It is a liquid at a higher temperature than its boiling point because it is pressurized. It is put pressure in order for it to remain in liquid state. So it is a liquid still at a temperature of 170 degrees Celsius. So it is superheated water. Its role is to melt the sulfur beds. Once the sulfur starts to melt, it will start to move up using the middle pipe L. Using the middle pipe L. And then as the melting continues, then there is the innermost that has got hot compressed air. The hot compressed air to maintain the molten state of the molten sulfur and water that is moving up in the middle pipe and also force it up. To force it up, to push it up in molten form. That is the role of the J. J has got hot compressed air that pushes up or forces out the molten sulfur mixture with the water up to the ground by maintaining it in molten state. I said the process is called Frasch process. F-R-A-S-C-H. Frasch process. And the process is made possible like that because water or sulfur is insoluble in water. That is why hot superheated water is used in melting because the sulfur is insoluble in water. The other reason, it is because the melting point of sulfur is low. The melting point is lower than 170. So you see it will be melted by 170 degrees Celsius because it is 115 degrees Celsius. So it has got low melting point, I said, and it is insoluble in water. That is why superheated water is used in that process. Then the two allotropes of sulfur are the rhombic sulfur and number 2, monoclinic sulfur. Rhombic, R-O-M-B-I-C, rhombic sulfur, which is formed below a temperature of 96 degrees Celsius, and monoclinic sulfur, which is formed at a temperature above 96 degrees Celsius. Those are the two allotropes of sulfur. And of course, an allotrope is the crystalline form of an element with different forms at the same physical state. So we have now the rhombic, which is tetrahedral. That is a different shape from monoclinic, which are long precincts. And yet, both of them are made of sulfur atoms. So they are allotropes because in the same physical state, one forms the tetrahedral shape, that is the rhombic. The other one will form long precincts. That is now how they are said to be allotropes. And of course, they are formed from pure sulfur. They are formed from pure sulfur. So we can continue with the next question. We can move to the next question. We can continue with the next question. The question below. Now that we are done with the allotropes of sulfur, and allotropes of sulfur, I said one is rhobic, which is formed below 96 degrees Celsius, and the other one is monoclinic, that is formed above 96 degrees Celsius. I am using 96 because 96 is the transition temperature. We can move to the next question. We can move to the next question below there. And as I said, you are doing correction, you are marking your work. That is the purpose for this lesson, to ensure that the assignment that you have done, and we keep on marking. As we also think about other allotropes that we have come across are like diamond and graphite, which are allotropes of carbon. They are also pure forms of carbon, and they are crystalline. Diamond is diamond will be tetrahedral, and then graphite is layers. Those are other examples of allotropes that we have come across. We move now to the next question, the question below. Commercial sulfuric 6 acid has a density of 1.8 grams per cubic centimeter. Calculate the molarity of the acid. Determine the volume of the commercial acid in the above 500 cubic centimeters of 0.2 molar. Sulfuric 6 acid solution. We can first of all jump that question because we have not learned how to calculate moles. Because it is about molarity, it is about moles, and we have not yet learned that part. We move to the other question of oleum. Oleum is an immediate product Iridium is an immediate product in the industrial manufacture of sulfuric 6 acid. Iridium, that is H2S2O7, is an immediate product in the industrial manufacture of sulfuric 6 acid. How can iridium be converted to sulfuric 6 acid? How can iridium be converted to sulfuric 6 acid? In that part of the contact process, that is manufacture of sulfuric 6 acid, once from the catalytic chamber, the sulfur 4 oxide is reacted with oxygen to form sulfur 6 oxide. The sulfur 6 oxide, if sulfur 6 oxide is put in water, the product will be sulfuric 6 acid. But that reaction is not done directly because it is highly exothermic and it cannot be maintained because it produces a lot of heat and mist of sulfuric 6 acid are formed. So it is, first of all, the SO3 is first of all added concentrated sulfuric 6 acid to form iridium. Now the iridium, which is H2S2O7. Once that concentrated liquid is formed, now the question we are answering is, how is it then converted back to sulfuric 6 acid? Simply by adding water, just to dilute it. You're adding water. So when iridium, H2S2O7 in the question, is added water, now it dilutes to concentrated sulfuric 6 acid, which is H2SO4. In that reaction, in the contact process, it is called the dilute because it is simply diluting the iridium to concentrated sulfuric 6 acid. And once that dilution is done, that is the final product of the contact process, forming around 98% of the concentrated sulfuric 6 acid. Then on the uses of sulfuric 6 acid, it has got quite a number of uses, e.g. it is used in lead acid accumulator, the car battery, as the electrolyte there. So it's used in the lead acid. We call the car battery now, we call it the lead acid accumulator. That is one use of sulfuric 6 acid. Then the other use, it is used in baking. It can be used in as a solvent in the making of solvents. It is used as a solvent in making of dyes and paints. That's another use of sulfuric 6 acid. Differentiate between a breaching action of chloride and sulfur 4 oxide. Differentiate between the breaching action of chlorine. It should be chlorine, not chloride. The breaching action of chlorine, not chloride, and that is chlorine gas and sulfur 4 oxide gas. Both of them are breaching. Breaching action of chlorine and that one of sulfur 4 oxide, they are different. The similarity is that both of them remove color. the color that is there. So they are able to remove the color. That is why they are called bleaching agents. Let's start with how chlorine bleaches. Chlorine will bleach by oxidation. How? When chlorine is put in water, it forms two acids. That is the chloric 1 acid, HClO, and the hydrochloric acid, the HCl. That solution that is formed is a yellow solution, and it is called chlorine water. The chlorine water, is yellow because of the chloric 1 acid, because the hydrochloric acid is colorless, of course. And that chloric 1 acid, it is not a stable acid. When it is exposed to light, that is, to sunlight, it decomposes to form hydrochloric acid and oxygen, the oxygen that we call the nascent oxygen. After it is decomposed, now the color will change to colorless. Therefore, chlorine is a bleaching agent because it is able to form chloric 1 acid when it is put in water. And the chloric 1 acid is the bleaching agent because when a dye, we can give an example of a red dye. When a red dye, or when red flower petals, or when we have any red dye, or even flower petals, or any colored substance, when chlorine is bubbled in its solution, because there must be water in order for the chlorine to bleach. When the chlorine is bubbled in that wet colored substance, the chlorine will dissolve in the water and form the chloric 1 acid. Then the chloric 1 acid plus that color, let's say it is red dye, and the product that will be formed will be the decolorized dye plus the oxygen and decolorized dye plus oxygen. That is one product. The other product is going to be hydrochloric acid. So in that case, the dye was decolorized because it was added oxygen. That is oxidation type of bleaching. The colored dye is added oxygen. The combination of the dye with oxygen makes it to be decolorized. So the dye is added oxygen and it becomes colorless because of that addition. That is oxidation. Addition of oxygen is oxidation bleaching. And that type of removing the color is said to be a permanent bleaching, because even on exposure to air, it will not be interfered with air because it was bleached by adding oxygen in it. Then when it comes to the one of sulfur 4 oxide, the one for the sulfur 4 oxide, when sulfur 4 oxide is put in water, it forms H2SO3, the sulfuric 4 acid. When sulfuric 4 acid is in solution form, we have the sulfite ions and the hydrogen ions. The bleaching part comes in when the SO3 is added oxygen. Of course, it will form SO4. Now, the source of this oxygen will be the other reactant. So if you have got red dye plus the sulfur 4 oxide, of course, the sulfur 4 oxide in the solution of the dye will form sulfur 4 acid, which is the SO3 ions. Then when they get the oxygen from the dye, now to form the stable SO4. And so the oxygen was got from the dye. The oxygen to change the SO3 to SO4 was got from the dye. So the dye is minus oxygen. And so the dye minus oxygen is decolorized. Dye minus oxygen is decolorized. And that is reduction. The breaching agent has taken the oxygen from the dye. That is breaching by or breaching through reduction. That breaching is not permanent because this dye without oxygen is decolorized. So once it is exposed to air where there is oxygen, the dye obtains oxygen from the air and it gets back to its original color. So that type of breaching is not permanent. It is temporal breaching. And it is also called, it is reduction. And that is how we differentiate the breaching of chlorine and the breaching of sulfur 4 oxide. Chlorine is by oxidation, sulfur 4 is by reduction. Is concentrated sulfuric 6 acid a weak acid or a strong acid? Explain your answer in one above. Concentrated sulfuric 6 acid, is it a weak acid or it is a strong acid? What is a strong acid from what we have learned? A strong acid is one that when it is put in water, it will completely dissociate to give hydrogen ions. So it will be having many hydrogen ions in the water. Then a weak acid or weakly acidic solution is one that when it is put in water, it does not completely dissociate to form hydrogen ions. So the solution will be having very few hydrogen ions. So the number of hydrogen ions are the ones that are making one to be strong, the other one to be weak. So concentrated sulfuric 6 acid, as we have seen earlier there, it is 98%. 98% sulfuric 6 acid, and the 2% is the water. So that acid has got very little amount of water, and more of that solution is in molecular form. The solution has got more molecules than ions. 98% are H2SO4, H2SO4 molecules. And so it can only be weakly acidic. Reason, it has got very few hydrogen ions. Around 2% of it is a part that can form hydrogen ions. The other part is in form of molecule because liquids are in molecular form. They only become ionized if they dissolve in water. But if we can give it now, we can ask, is dilute sulfuric 6 acid a weak acid or a strong acid? The answer is it will be a strong acid because now it will be having many hydrogen ions in that water, in that solution. So dilute hydrochloric acid, dilute sulfuric 6 acid, dilute nitric 5 acid are strongly acidic. Reason, when they are put in water, they form many hydrogen ions. If a solution has got many hydrogen ions, it is said to be strongly acidic. The other question is, in the manufacture of sulfuric 6 acid, sulfur 4 oxide is oxidized to sulfur 6 oxide. Name the catalyst. Of course, the catalyst there is platinum. It will be platinum if it is done in the laboratory setup. Then we have learned putting sulfur 4 oxide and oxygen in a laboratory setup, we use platinum. But now in large scale manufacture, like the way the question states, in large scale manufacture, the catalyst that is used is vanadium 5 oxide. Reason, it is cheaper. Another reason, it is not easily poisoned. But the diagram that we have drawn in forming SO3 from SO2, we use platinum in the laboratory setup. But in the industrial process, I said vanadium 5 oxide is used because it is cheap and it is not easily poisoned by catalyst. The last question, write an equation representing the conversion of sulfur 4 oxide to sulfur 6 oxide. Definitely that one will be SO2 plus O2 to get SO3. And then we balance the equation by putting a 2 in front of SO2 and a 2 in front of SO3. A 2 in front of SO2 and a 2 in front of SO3. So that we have on the reactant side 2 sulfur, on the product side 2 sulfur. On the reactant side 6 oxygen, on the product side 6 oxygen. So that one is balanced. Then explain using equation how dilute sulfuric 6 acid is finally obtained from sulfur 6 oxide. From sulfur 6 oxide, SO3 in the contact process is first of all added concentrated sulfuric 6 acid to form H2S2O7, that is oleum. Then the oleum, as we had seen earlier on, H2S2O7 is added water to form sulfuric 6 acid. So in that case, you write the two equations. How to form sulfuric 6 acid from sulfur 6 oxide is by, first of all, forming the oleum. Then the oleum is added water to form sulfuric 6 acid. Can end our lesson there. We can lesson for the day, and it was a good lesson. I hope all what I have gone through, you have done correction. Have a good day.